Alright, Algebra 2, let us go ahead and use composition to determine if f of x is equal to 4x minus 3 and g of x is equal to x plus 3 divided by 4 are inverses of each other. Alright, so let's go ahead and get started on this problem. Alright, remember that if we plug both of these functions into each other, we should just get x. Alright, so let's go ahead and get started. We have f of x equals 4x plus 3. So let's do this over here. So we have f of x. We're going to plug in g of x into our function, right? We're taking this and we're plugging it in for x. So we're going to first have, and I'll use color coordination just like before. All right, we're going to get f of x and then is equal to f of g of x. All right, well, this is the same thing as f of x plus 3 divided by 4 is equal to, all right, I'm going to take this and I'm going to replace it for x. So we're going to get 4 parentheses x plus 3 all divided by 4, all right, minus 3. All right, let's go ahead and see what we get. Well, what's 4 divided by 4? Well, 4 divided by 4 is just 1, so we get x plus 3 minus 3. Well, what's 3 minus 3? Well, that's just 0, so we get x. So finally, we can conclude f of g of x is equal to x. All right, let's go ahead and do it for this function over here. So we have g of, let's plug in f into our function, f of x, 4x minus 3. All right, now we're taking this entire thing and plugging it in for x up here. All right, it's our input, so we replace the entire thing. So we're going to get g of 4x minus 3 is equal to, all right, parentheses, 4x minus 3 plus 3 all divided by 4. All right, and so finally we're going to get, well, we're going to have 4x, 4x minus 3 plus 3 all divided by 4. All right, I'm going to scroll down a little bit here. All right, well, what's negative 3 plus 3? Well, that's just 0, so that's gone, and we're going to get 4x divided by 4. Right, what's 4 divided by 4? That's 1, so we get x, right? And right up here we had g of f of x. Right, that's what we plugged in. G of, I'm just going to write it in, all right, f of x and g of f of x. All right, so just like we did on these problems, when we plug both these functions into each other, we got x. We got back our point of reflection. Therefore, they are inverses of each other. Perfect. All right. So let's go ahead and try solving maybe a more complicated problem here. All right. So here we go. Let's go ahead and get started. All right. We have f of, let's plug in g of x into our function. All right, this is the same thing as f of, it looks like our entire function we have here is x plus 2 raised to the 1/3 minus 1, okay, which is equal to, so now we're taking this entire thing and we're putting it in for x, as crazy as that may sound. So we're going to get parentheses here. We're going to get x plus 2 raised to the 1/3 minus 1. All right, put an extra set of parentheses, right? We're gonna close the parentheses, changing the color, sorry, plus 1, we close the parentheses, raised to the 3rd power minus 2. If you notice, what I did is I took this entire thing here, I took the entire expression, as crazy as this may be, and I plugged it in for x right there, which you can see that I just replaced x and put this entire thing in there. All right, so we did that. Let's go ahead and scroll down. We're going to get into our function. We're going to get, all right, so we're going to get f of, I'm just going to write it as g of x. All right, we know it was this right here. That's what we plugged in, is equal to, well, we have, what's negative 1 plus 1? Well, that's just 0. All right, so we're going to get x plus 2 raised to the 1/3. I know I kind of changed colors on this by accident, sorry. raised to the third power minus 2. All right. Well, what's 1 over 3 times 3? Well, that's just 1. All right. So f of g of x is going to equal, well, we're just going to get x plus 2 minus 2, which is the same thing as x plus 2 minus 2. 2 minus 2 cancel, and we just get x. Back to our point of reflection, which is exactly what we wanted here. All right. Now, finally, there's one last step that needs to be done, which is we need to do the same thing up here, right? So we need to, all right, plug in f of x into our function, into this function now. So we have to plug it into both of these, all right? So we're going to get g of, we're going to get, looks like x plus 1 raised to the third minus 2. So we're taking that and we're putting it into our entire function. So let's go ahead and scroll down below. All right, I'm going to do this right here. So we're going to have g of f of x is equal to, all right, we're going to get, let me go ahead and show you. All right, we're taking this entire thing and we're plugging it in for x there, as crazy as that sounds. So we're going to get x plus 1. Oh, sorry, get the same color. We're going to get x plus 1 raised to the third power minus 2. Okay, this is the entire thing. Plus 2, right, raised to the 1/3 minus 1. All right, so if you notice, this should be plus 2 here. All right, this is from our original function. Sorry, let me just go ahead and rewrite the plus 2 so it doesn't look confusing. Plus 2 raised to the 1/3 minus 1. All right, so if you notice, all I did was I took this entire expression and replaced it with x, which you can see it's right here. This used to be x plus 2, but now I replaced the entire thing there. So now if we scroll down, all right, well, what's negative 2 plus 2? Well, that's 0. So we're going to get g of f of x is equal to x plus 1 raised to the third power all over 1 to the third minus 1. Well, g of f of x is equal to, well, it's 3 times 1/2 up here on the exponents. Well, that's just 1. So we get x plus 1 minus 1. 1 minus 1 is 0. So finally, we get that g of f of x is equal to x, which is exactly the same thing that we got for both. When we plug both of them into each other, we get the point of reflection again, which is x. We get back to the starting point. So they are inverses of each other. Whew, that was a tough one, right? But we got through it and we worked through it together.